to the Let's Talk Crypto podcast, where we discuss the latest Bitcoin, blockchain, and digital asset news.
Hi, everybody. Welcome to Let's Talk Crypto. Today, we are going to cover some fundamental basics with regards to the crypto space. We want to try and help those of you who are new to the space to learn some of the basics and grasp some of the things which you can build upon going forward. Slava, what is a blockchain?
Blockchain is a technology which allows users all over the world to make transactions. The most typical use case for blockchain is Bitcoin. The most famous use case for a blockchain is Bitcoin. Bitcoin blockchain is a decentralized ledger where there are many different nodes that store transaction history. So what happens is that if, for example, Wes, I want to send you Bitcoin over the Bitcoin blockchain, I get your address, I input your address, and I send the transaction to the network. Once the transaction is accepted on the network, the cryptographic proof of the transaction is created, and all of the nodes in the network have to accept that as true.
Okay. What is a node, Slava?
Okay. A node is a computer that contains the database of all transactions in the blockchain. So it's basically a history of transactions. And because Bitcoin blockchain is a decentralized technology, you can have as many nodes that do certain work that fulfill the same function. Whereas in a centralized system, you have a central server that communicates the transactions from one agent to another.
Okay, but fundamentally, the difference between, for the user, sending money from one person to the other, what is the difference? I can send money from my bank account to another person's bank account, much in the same way that a person can send Bitcoin to another person's wallet. What is the difference? What is blockchain for? What purpose does it have?
Well, in blockchain, there is no central authority, right? And therefore, it's an open ledger. So first of all, you can make sure that your transaction has been delivered to the recipient, and you can see all the history of all transactions. Therefore, it's really difficult to manipulate the system. From the business perspective, one of the benefits is that there are no chargebacks. So it's like a cash. If I give you the cash, you have the cash. No one can reverse that. And therefore, that lowers down the transaction costs.
Suyash, is there anything you want to add with regards to blockchain?
On my end, the way I see blockchain technology is actually a set of technologies. It's not something new. I would say that blockchain is based on a set of technologies, but these technologies have been around for quite some years. And it's not something new, but the novel part of the blockchain is how these technologies are used in conjunction to create a decentralized and trustless system. If you take the example of the Bitcoin blockchain, it uses a lot of technologies like the hashcash function, which was originally created to tackle email spams. And that's very interesting, actually, because actually, these technologies have been around for like 10 years before Bitcoin was launched. But the interesting part, very intelligent part, is how this was used to create this trustless and decentralized environment, which is created by the blockchain technology.
Okay. Omar, is there anything you wish to add?
Blockchain itself, it's just a data structure in its basic form, and it was actually invented by Dr. Stuart Haber and his colleagues in 1991. And if you look at the Bitcoin white paper and you go to the end of the white paper, you will see a number of references to people's work that was actually done quite a long time before the Bitcoin white paper was actually released. And originally, some of the blockchain was proposed to be used to basically timestamp, to do timestamping of digital documents so that it would not be possible for someone to tamper with them by, possibly backdating them or corrupting the files.
By going back and changing the history, basically.
Yeah, that was the original idea. And although that was the original idea, that idea was extended further. They took the concept of immutability and they added they made a ledger out of it, which is now digital, of course. It's distributed. It's publicly accessible in the case of Bitcoin, and it's basically implementing a decentralized way of transferring monetary value, which we now know is not the only use case. And I was interested in explaining more of like where the hash value. So if you have hash functions, for example, if I have a chain of blocks, that's what it is, right? A blockchain is a chain of blocks, and each block contains a data set or a set of transactions and a hash that is a unique hash value. A block contains the hash value which is linked to the previous block, and that these hash values end up linking the blocks together. And I think this is what makes it very difficult to alter or corrupt the history of a blockchain, because you would have to undo all of those hashes, and because it's proof of work, you'd have to spend a lot of electricity to do that. That's what makes the network highly secure.
Sure. Okay. Before we go too deep into that, Slava, what is the difference between Bitcoin and the Bitcoin blockchain?
So think of a blockchain as an ecosystem that is working according to certain rules. So as Omar just mentioned a few moments ago, hash functions is one of the key elements of the blockchain that allows the blocks. So Bitcoin is in a sense an entry in the ledger. So for example, just like in a bank or in any database, each person has a bank account, and that person would have a list of debits and credits associated with that account. So when we're talking about Bitcoin blockchain, it's a semi-anonymous blockchain. We cannot see the names of people, but what we can see is a wallet address and the balance of each individual wallet address on the network.
And that's represented by a list of unspent outputs.
Yes. So an unspent output is something that helps to prevent double spending, which is very characteristic of a blockchain. So an unspent output is basically how much money you have left in your wallet, and that's after the transaction has been completed. So for example, Wes, if I have 10 Bitcoins in my wallet and I give you 7, therefore the unspent output would be 3.
Okay, got you. And now that's the Bitcoin blockchain. The question being to differentiate between Bitcoin and the Bitcoin blockchain. You're saying, essentially Bitcoin is the unit of account, basically, on the Bitcoin blockchain, and what it's accounting for are the unspent outputs with each user address or user wallet. Is that correct?
That's a very good and precise definition. Yes.
Okay. So we've also touched on double spending. The double spending problem. What is that?
It's where the same amount of funds, user funds or funds that are on a network, nobody should be able to spend the same funds on more than one occasion or to settle more than one transaction at the same time. So in order to safeguard against that, algorithmically, there's a set algorithm, or which is part of the Bitcoin protocol now, or has been, to prevent users from spending the same unit or the same Bitcoins twice.
Correct. And it does that by employing proof of work, make it expensive to reproduce a block.
Yes, proof of work does that in addition to a few other things.
Yeah, just to add to that, one of the to give a bigger picture of the whole double spending problem is the fact that since the start of the computing industry, digital files or digital assets or any digital entity can be easily copied, and that's a big issue. You can assign value to a digital entity if it can be easily copied and replicated millions of times over. So the double spending problem really stems from this specific problem. So how do we assign a value to a digital asset and make sure that it can be replicated easily. The basic idea behind proof of work is, okay, you have a digital asset, so you need to prove that this digital asset exists and is assigned to a specific, let's say, user or address. And to prove that, you need to spend a lot of energy and eventually a lot of money. So what happens is that if you want to do any change to that, you want to create a new one or anything like that, you need to put some work. That's why it's called proof of work. So basically, the blockchain technology, or more specifically the proof of work, what it really does is really make digital assets unique and valuable. That's the basic, I think, in my opinion, that's the basic idea behind proof of work and the double spending problem.
Correct. And I think a great example is a PDF document. If you had a PDF document, who's to say there aren't 50 copies of that PDF document? You just copy and paste, and you can send it to the same document, what appears to be the same document, to 50 people. And the problem that arises there is, if you want to create something of value, monetary value, especially like money or currency itself, digitally, it's too easy to forge or copy or duplicate. And I think that's where the proof of work stepped in and solved that problem. I think in terms of another problem that the blockchain solves, or at least in the case of the Bitcoin blockchain, is the Byzantine generals problem, which in computer science was basically getting different entities, or different, I think entity is a great word, to agree on a single strategy or on a single event, if I can put it that way. And the Bitcoin blockchain, or a blockchain, solves that via the proof of work algorithm. There are other consensus algorithms. Do you want to just give us a brief intro on that, Suyash?
Yes, sure. So I think the most popular one is the proof of work, which is really a way of securing the network by putting a lot of effort. That's what the name proof of work really means. So apart from this, we have proof of stake, which is becoming quite popular, because even Ethereum is planning to migrate to a proof of stake consensus algorithm. A proof of stake consensus algorithm is quite different in the sense that it doesn't require a lot of work to prove that something has been done or a transaction has been created. Instead, there will be a set of, they won't be miners as such, but we call them validators. And the aim would be to validate all the transactions. So how do we pick these validators is by checking how much they have staked their funds in the network. Let's say, for example, Ethereum is using the proof of stake, and I have in my balance in the Ethereum blockchain 1,000 Ether. And let's say Slava has 100 Ether. So I have basically 10 times more, a higher probability to validate the next block and get the rewards associated with that. So there's a lot of things which comes afterward, like, is it a fair system, and does it not favor the ones who have more stake on the blockchain and things like that. But this is really a whole different, it could be a different topic that we could discuss on. You have proof of work, proof of stake, you have delegated proof of stake, and something that is very, let's say, I would say common is proof of authority, which is quite similar to proof of stake, but where you don't stake funds, you don't stake cryptocurrencies, but instead you stake your identity or your reputation. So basically, how does this work is we pick and choose 10 validators which are made public on the blockchain, and to be part of the blockchain, they need to have a good, let's say, have a good behavior on the blockchain. So this is how it works. And if someone has a bad behavior on the blockchain, then his reputation will be affected. So it's quite similar, but it's quite different in some of the ways. So basically, that's the three main consensus algorithms out there.
Okay, if we just go back to proof of work, how does it actually work? What has to take place? You've got a miner. I'm a miner now. I connect to the network. What actually happens? What do I need to do? What is proof of work? What happens to validate these transactions? And how do I get rewarded?
After you connect to the network as a miner, you immediately start solving a riddle. So basically, in a nutshell, what happens is that you try to open the key by randomly choosing the passwords. So the more computational power you have, the faster and the higher probability that you will be the first to solve the riddle and open the lock. So what happens after you open the lock is that you create a new block. What is the purpose of the block? Now, after the new block has been created and is attached to the chain, you can add transactions to that block.
The riddle that needs to be solved, perhaps you could tell me how I get rewarded and how that all works.
So as a miner who created the new block, who opened the new block, there are two things that happen. First of all, you get the Bitcoin, which is automatically appears, is being minted on the network, and you become the owner of the Bitcoin. So that is your reward to mine new blocks. And also, and here, correct me if I'm wrong, is that the transactions that are waiting to be added to the chain are added to the chain because the new block is being created. It has been created. But each transaction has a small reward that miner takes home as a fee to add transactions to a block.
Correct. There is a transaction fee, but there's also something called the coin base. And what happens is the miner is rewarded that amount. At present, I think it's sitting at 12.5 Bitcoins per block. So every 10 minutes when a block is added to the chain, 12.5 new Bitcoins are released out of the 21 million, and that goes to the winning miner, the miner who solves the riddle first. So transactions are validated, they're added to a block, the block riddle is solved, and then that block is added to the chain.
I have a question, guys. Actually wanted to ask because as I was talking, I thought that I'm not sure whether the same miner So let's say I'm the miner, I open the block, I get the reward. Am I going to get the reward for adding transactions into the block? Or is it going to be a different person?
You will get the transaction fees from that block, yes.
Okay.
All the transaction fees that accrue in that block go to you. You get everything. It's winner takes all.
So I believe here the original question, what is proof of work? And just a little bit of history is that why would you do proof of work? One of the main reasons is to prevent spam or cyber attacks. It's also called distributed denial of service attacks. And because if you get many spam transactions on your network, that can be a way that an attacker can clog up the network and prevent other users from actually using the network. And Hal Finney, if you guys remember, is the guy who came up with this idea around 2004. And it was after he came up with this idea, it was used to write the Bitcoin. It became part of the Bitcoin white paper. And when we have full node on a Bitcoin network, when we have miners and we also have full node operators, right? So these people have downloaded the entire transaction log history ever since the first or the Genesis block for Bitcoin was produced about 10 years ago. These miners must execute proof of work, meaning they have to use their computing power, they have to use their electricity to guess random numbers, because you have to guess the right numbers to produce the unique hash value. And it's basically not solving complicated math problems. It's just doing a very difficult job of guessing the right numbers.
Yes. It's just a very long number, and one has to get the right permutation of it to equal a certain hash, and it's quite resource intensive. So that's why it's used as a proof of work, because one does have to expend a lot of energy in order to realize the correct value.
That's the people who recommend proof of work for blockchain consensus argue that that's what gives the coins their value, because it's unforgeable. It's an unforgeable way of creating value. if that's possible. So that's why the coins have value, because it took real computing power and people's resources to produce those coins.
Correct. And then what proof of stake is, the principle behind that is to take that and turn it on its head and saying, instead of burning that energy and perhaps doing damage to the planet, to the environment, you are investing money in electricity and resources to get those answers and to produce proof of work. Why not have a situation where you take that same amount of money in terms of resource and stake it and then be a validator of sort? So, and then proponents of the proof of work system will turn around and say, proof of stake is not preventative in terms of forgery. You only know after the fact when something's gone wrong. So that's quite a difference between proof of work and proof of stake. Is the proof of work requires the resources upfront and will cost money to forge, whereas with proof of stake, what they'll say is, once the forgery is done, it's only then that there will be a cost associated with creating that forgery.
Yeah, there are several ideas that are debated. A couple other things while we're on proof of work is that on average, every 10 minutes, a new block is produced by miners. So every 10 minutes, a new block is generated on average. And to be very correct, very precise with the terminology, transactions are verified and blocks are validated. You verify transactions and you validate blocks. So, but having said that, you can still kind of use those words interchangeably at times.
Okay. What is a smart contract?
I like this question because it falls really in my category of things that I deal with every day, smart contracts. So what is the smart contract? I would say that a smart contract is just a simple construct or a simple software which runs on a blockchain. The software may be very simple or maybe very complex, but it has a set of responsibilities, and usually it's defined to do something. It could be something very simple, like to transfer cryptocurrencies from one point to another or to store cryptocurrencies, but it's really well defined. Why? The simple reason is that when you write a piece of software, be it on a blockchain or on a traditional cloud-based system, a software by definition is very specific. So you know that the software needs to do a list of functions, need to perform a list of functions. But the same applies for smart contracts. But the different thing with a traditional, like say, software, a smart contract is what we call self-executing. That is, based on certain conditions, it will execute, and it's actually impossible to stop it from executing. Okay, and the good thing about that is you can write really decentralized applications. This is what we call DApps, so decentralized applications, which can run on their own. And it's not like, let's say, a very simple analogy would be Facebook, where there is a single entity, that is the Facebook company, which manages everything. So if tomorrow Facebook decides to shut down, you lose everything, all your pictures, your messages, your photos, and things like that. And you don't know how your information is being used. A smart contract, if you take it in a traditional sense, that is in a public blockchain where the code is publicly available, offers very contrasting attributes in the sense that the information that you store is publicly available. That doesn't mean that the information is public. It's just that a form of it is publicly available. And number two, you can clearly see how information is being used. So basically, what smart contracts offer is a set of constructs to allow you to create decentralized applications.
Smart contracts, is that something that's unique to the Ethereum blockchain, or do you get it on other blockchains like Bitcoin, for example?
There are many blockchains that have smart contracts. And surprisingly to many people, Bitcoin is not an exception. Bitcoin blockchain is not an exception to that. The functionality of a smart contract has been introduced to Bitcoin blockchain a while back. There are several use cases, and one of them is multi-sig or multi-signature feature, which allows to, for example, send a transaction only if more than one person has signed the transaction. So, for example, if we are running a common account for a business on Bitcoin blockchain and there are two co-founders, so you have to have the signature from both people to authorize the transaction and send money from that account. Unlike Ethereum, Bitcoin's smart contract functionality is limited. It's not as developed as Ethereum's or other blockchains which were built around the notion of smart contract. But nevertheless, we can find many different use cases for Bitcoin blockchain and embedded functionality of smart contracts.
Sure. I mean, smart contract by definition would just be a contract which is self-executing when certain conditions are met. So definitely multi-signature wallet or multi-signature transaction would constitute a smart contract of sort. Another one that comes to mind, which utilizes the multi-signature format and relies on it, I believe, if I'm not mistaken, would be Lightning Network. Or is that not the case?
You can program smart contract functionality. You can integrate it with the Lightning protocol depending on what you're trying to do. But taking a step back, like what exactly is a smart contract? It's all it is lines of code. It's just it can even be referred to maybe as a function or a procedure call that performs a certain task based on a specific set of conditions. If those conditions are met, those lines of code are executed. And if those conditions are not met, then those lines of code are not called upon. And with Lightning Network, that's a layer 2 payment protocol. And there are different implementations of that protocol. And if necessary, depending on the type of app you're developing, you can decide to start writing the smart contract. But to be very clear, the term itself, a lot of analysts and experts have said it's kind of a bit misleading, because smart contracts doesn't mean we get rid of some sort of human involvement, because, for example, it would be incorrect to say that because we have smart contracts, we don't need a lawyer. That's not the thing. You do need legal counsel. You do need people to work. So these contracts, they are complementing what professionals are doing by making their life and their work more efficient and effective, but they are not a replacement yet, at least for certain things that
well, I think what would help is if you had a real life example. When would you expect to see a smart contract? What would be a great use case?
Sure, I can give you a personal example and a business one. For instance, Brock Pierce, the childhood actor from Mighty Ducks, and then one of the people behind EOS initially, and he's kind of active in the blockchain space. His wife, him and his wife, they have a digital marital contract. So the smart contract renews itself every year, depending on whether Brock and his wife, Crystal Rose, decide they want to renew their marriage vows every year. So they both have to go in, they have to select an option where they say, yes, we want to renew our marriage, and it's managed by a smart contract. And then if you want to look at it at a business type of business thing, banks, financial institutions, they can write programs that use smart contracts to determine whether or not to allow certain applicants to receive loans, or people's salaries can be determined and given out to them based on certain conditions. So these are things you can take a regular contract that you see on pen and paper, or you see in a digital form, and you can automate its execution to a certain extent
Okay. All right. Fair examples. Suyash, do you have any other examples?
Yeah, sure. One of the examples that I've been studying for quite some time is actually, let's take the hotel industry, the tourism industry. So just going to walk through a scenario and see how smart contracts can be really useful. So you are tourists, you come to, let's say you come to Mauritius because it's a beautiful island, and you go in your hotel, you have booked your hotel, and there's a smart contract between you and your room. And what happens is that you pay for the room via a cryptocurrency. Okay. And the room will only unlock if you can take your smartphone and sign and give a digital signature with your private key. So what happens is the hotel room will check with the smart contract if the funds have come from that specific user. And if it matches, then it lets the person in. So this system is completely independent and it works without any user interaction. It's all based on blockchain decentralized applications, and the payment is via cryptocurrency and things like that. So these kinds of systems could be extended to a lot of use cases where there are a lot of intermediaries.
Immediately what comes to mind is even a car rental business or even a taxi service. Driverless cars, perhaps an Uber that comes up without a driver, and you've made the booking, and exactly how you describe the room letting you in, the car lets you in, and it knows where you want to go, it drops you off, and it deducts your cryptocurrency from your wallet. I think that would also be quite a good tangible example. Bitcoin is based on open source software. Now, to the average listener out there, we're not sure what it is. It doesn't really mean much. What is open source software? And it also leads to the question, what is closed source software?
So traditionally, companies would create software. Something like Facebook has millions lines of code, but we don't really know how that product works. Why? Because Facebook, the company, owns the code and does not distribute it to the public. Therefore, this is an example of a closed source software. Blockchain and Bitcoin in particular it's an opposite of closed source software. Anyone can go to a website and download all of the software, which shows the rules and regulations which Bitcoin and all the players in the ecosystem follow. Moreover, you can create proposals, upgrade proposals, and submit them for the review. So for the Bitcoin blockchain, they're called BIP, or Bitcoin Improvement Proposal, that allows to extend functionality and make the blockchain more suitable for the conditions, more useful by adding functionality.
In that case, if you say it's open source, who owns the intellectual property behind it?
No one. If I remember correctly, it's an MIT license, which means that anyone can go and download the software, and it's a public domain.
So in other words, there's no royalties to be paid to any creator, developer, inventor. It's out there in public domain to be used as you see fit.
For the public and by the public and for the public. Yes.
And for final thoughts, I'd like to ask each of you here, what does Bitcoin mean to you? In one or two sentences, define what it means to you. Slava.
Well, for me, actually, it's how I was paid for some time, not currently, but it's just a means of transferring and storing value, which was very practical.
Fair enough. Omar, and yourself, what does Bitcoin mean to you?
It's a new way to accept and transfer value, because I don't actually know about you guys, but personally, like what I find it is that if I've done like a little bit of work, right, online, maybe a few $100s to say or something, and I'm not doing like thousands of dollars worth of transaction, I don't feel like giving somebody, sitting down or sending them my bank details and like all these things so that they can just send me a payment. It's easy enough for me to give them a Bitcoin address and they send the payment and I'm done. There's nothing else involved.
So it simplifies things. It simplifies things and brings finality to it. Okay. And Suyash, what does Bitcoin mean to you?
For me, from a technological perspective, I think that it's really awesome, like where it started and where it's heading. For me, I'm really happy that I am living right in the middle of this Bitcoin revolution. So I'm very, very positive about all the different potential new avenues that it will bring in terms of money, in terms of monetary policies and things like that. So yes, I mean, from a technological perspective, I'm really glad that I'm right here in the middle of it.
Awesome. For me, it's just a new form of money that lessens the interface time that I need to deal with banks and third parties. The unconfiscatable, uncensorable part of it is what I really like. And the store of value is something which I think that we don't find in any other asset to date.
Another thing I think I mentioned today is that it would have appeared as if I had lost my access to my wallet earlier this morning, and it appeared that way. So I, started looking here and there, and then finally, of course, what you need to do, this is part of management, because if you have your money at a bank, the bank is managing your money, right? You trust the bank to manage your money, and you log into your online account, everything is nice. But this morning, like, I received the message, your 2FA is not working or whatever, and I'm like trying to log in. Finally, I just restored my account by inputting my seed. So I just input my seed and I went through and I restored my account. But had I like lost my seed or not like known where I kept it or was not able to access it, my funds would have been gone, right? So this managing your 2FA, your password, your seed, and dealing with your Bitcoin account it's a bit of a learning curve, and some people might have to learn the hard way. The hard way would be to lose the funds and then.
Correct. That's the thing about this new type of money, is that with newfound sort of features and everything comes also personal responsibility.
And then right when you have the seed, right, where do you put it, right? There's some people say don't show your seed to anyone. Don't show it to anyone. Okay, if I can't show it, don't put it on your computer because someone might see it. Or if I put it on a piece of paper, don't lose the paper. What if it burns? What if somebody comes and snatches it? All these questions.
Omar, I'm not going to tell you where my seed is.